everybody, I'm Mohammed Hasan in the Mathematics Mentor. In this channel you're watching One Math and Me, and in this video we are going to be discussing the divisibility rules for 16 and 17, and we have the discussed the divisibility rules for 15 and 14 in the previous video. As you can see on the top, a small pop-up will come here, and now let's head into the session. So this is the divisibility rule for 16. We have to add 5 times the unit digit to twice of the remaining digits. So I have to take the unit digit over here, which is 8, and I have multiplied that with 5, and I'm adding that to the twice of the remaining digits. So my number over here is 3,748. I have taken my unit digit, multiplied that with 5, and adding it to the twice of the rest of the digits, and I get 788. As you can see, the number over here has drastically decreased. So after a few times, after repeating this process for a few times, I got the number 68, and 68 I can say that it is not divisible by 16 by just looking at it over here. So 68 is not divisible by 16, and so is the number, it's not divisible by 16. Now let's see how this works, the proof. I have my number over here, a, b, c, d, and its expanded form: 1000 times a plus 100 times b plus 10 times c plus d. And again, I have written that such that one term is at least divisible by 16. So I have written 1000 as 1600 minus 600, and 100 as 160 minus 60, and 10 as 16 minus 6, and 1 as 16 minus 15. Now I have expanded all the brackets over here and grouped all the terms which are divisible by 16. I have cancelled them out, because in order for this number to be divisible by 16, both of these terms should be divisible by 16, and we already know that this is divisible by 16. So the only thing I have to check is this number over here, and I have taken minus 3 common, as you can see, and minus 3 is again not divisible by 16, so we can just take that down also. Now I'm left with 200a plus 20b plus 2c plus 5d, and taking 2 common, I'm left with 100 times a plus 10 times b plus c plus 5 times d. Now over here, 100 times a plus 10 times b plus c is nothing but the expanded form for a, b, c, and this is 5 times my units digit. So that's the divisibility rule: add 5 times the units digit to twice of the remaining. So hence proved. Now let's see the next divisibility rule, the divisibility rule for 17. So it's quite similar, but you have to subtract 5 times the unit digit from the remaining digits. So I have my example over here, 845. I am taking my units digit, which is 5 in this case, and multiplying that with 5, which is 25, and I have to subtract it with the remaining digits. So 84 minus 25 is nothing but 59, and 59 is not divisible by 17 again. So 845 is not divisible by 17. So let's see the proof for that. So assuming that 10x plus y is my original number, so that is the expanded form for xy, where x is the tens place, in the tens place. So this is my number over here, 10x plus y is my original number, and according to my theorem, divisibility rule, x minus 5 times y equals to 17n, which is nothing but 5 times my unit digit minus the remaining digits equals to something divisible by 17. So we are assuming that x minus 5 times y is divisible by 17. So now we have to try to get the left hand side, which is x minus 5y, to look as our original number. So this is my original number over here, and for that I am multiplying both sides with 10 over here. I am multiplying this equation with 10. That is 10, I will get 10x minus 50y equals to 170n. I got that over here, and I am then adding 51y to both sides. So when I add 51y to minus 50y, I am left with positive y. So that's what I got over here, 10x plus y equals to 170n plus 51. Now if you observe that 10x plus y is our original number over here, so and 170n plus 51y is divisible by 17, so that's nothing but 10x plus y is divisible by 17. So that is proved, hence proved. So if the number 10x plus y is divisible by 17, then x minus 5y should also be divisible by 17. So that's the proof, and that's it for today, guys. I'll meet you in the next video. Subscribe to the channel if you didn't yet.